Today we're going to be talking about the angle-angle postulate for triangle similarity. The angle-angle postulate. Remember, postulate is something that is accepted without proof. It says that if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. So here I have triangle ABC and triangle DEF. I have angle A congruent to angle D, angle B congruent to angle F. So triangle ABC is going to be similar to triangle DFE. Make sure you have the corresponding parts labeled correctly. I have angle A equal to angle D, which is true. Angle B equal to angle F, which is true. Our first example, find AB and BC. Since we have parallel lines, AC is a transversal, so A is equal to C, and E is congruent to D. So I have, by the angle-angle postulate, triangle A, B, E, similar to triangle. I'm checking my corresponding parts now. I started with A. I have to go to C, B, D. Now let's look at what pieces we know from each triangle. In triangle ABE, I know side AB. So AB is proportional to the corresponding part in the other triangle. That's going to be BC. AB, BC, or CB. That's equal to, well, I know EB in the larger triangle. So EB over BD. Now it's just a matter of filling in what we know. AB is x plus 3. BC, 2x minus 8. EB is 5. BD is 3. Now we cross multiply. So 3 times x plus 3. That's 3x plus 9. Cross multiply. We get 10x minus 40. I'm going to subtract the 3x over to get a 7x. Add the 40 over to get 49. X is going to be 7. Make sure that you are checking. What am I trying to find? I'm trying to find AB. Well, I know x is 7. AB is 7 plus 3, which is 10. I'm trying to find BC, which is 2 times 7 minus 8. 14 minus 8, it's going to be 6. Now do a check. 5 over 3 is our scale factor. Check and make sure that AB, which is 10, over BC, which is 6, 10 over 6 equals what our scale factor is, and it works out. The next one, solve for AB and AC. Now we have a triangle with a segment. We don't know it is the mid-segment. And this is going to be a little bit more important to us later on in our chapter. But we have a parallel line where EB is parallel to DC. Well, AC is a transversal. So angle ABE is equal to angle ACD because corresponding angles are equal. Similarly, angle AEB is equal to angle ADC because corresponding angles are equal. So I have, again, triangle AEB similar to triangle ADC. So now we need to set up our proportion. Well, in the smaller triangle, I know side AB is x plus 2. So I know in the smaller triangle, AB over AC, well, that's corresponding pieces. I know the whole side in the larger one. So I know all of side AD. The corresponding part in the smaller triangle would be AE. AE is 8 minus 5. The whole segment is 8 minus 5. That's going to get us 3. So AB, start setting up a proportion. AB, x plus 2 over AC. The whole segment of AC is x plus 2 plus 6. AE is 3. AD is 8. So I have x plus 2 over x plus 8 is equal to 3 over 8. Cross multiply. 8x plus 16 is equal to 3x plus 24. I'm going to subtract the 3x over to get a 5x. I'm going to subtract the 16 over to get an 8. X equals 8 fifths. Sometimes we're going to have funky fractions, and that's okay. So AB is what I'm looking for. Is equal to 8 over 5 plus 2. 2 is 10 fifths. So AB is equal to 18 fifths. What else am I looking for? I'm looking for AC. So AC is AB, which was 18 fifths, plus 6. 6 is 30 fifths, so I have 48 fifths. Is equal to what AC is. Now we have a proof, and this is from your book, where we have triangle PQR similar to GHI, and PS and GJ are angle bisectors. I need to prove, and I'm going to highlight this a certain way, PS over GJ is proportional to PQ over GH. Now remember, the only way that we have to prove triangles similar is by the angle-angle postulate. Well, look at what I've highlighted. I've highlighted two sides in triangle PQR or PQS and two sides in GHJ. How could we get those triangles similar? Let's just talk through it, and that's how you may want to start some proofs. Mark up what you know. We know triangle PQR is similar to GHI. So because the corresponding angles in similar triangles are congruent, Q is equal to angle H. I also know the whole big angle, QPR, is equal to HGI. Because they're angle bisectors, because PS is an angle bisector and GJ is an angle bisector, I know that if I cut two angles that are congruent in half, half of the angles are going to be equal. So therefore, angle 1 is going to be congruent to angle 2. So now we have our triangles congruent by angle-angle, and thus we can now say that our sides are in proportion. So let's take a minute and let's write this down. I'm going to split the board so that I can have this picture up along with our 2-column proof. Okay, so we are given that triangle PQR is similar to triangle GHI, and PS and GJ are angle bisectors. So we are given that, and I've written that out. Now, I've talked through the proof in the last one, so let's write down what we talked through. We talked through that our corresponding angles in similar triangles are congruent. So I knew that angle Q was congruent to angle H, and that angle QPR was congruent to angle HGI by, now watch my abbreviation, corresponding angles of similar triangles are congruent. Now I need to get angle 1 congruent to angle 2. Going to take a few steps. 1/2 of angle QPR is equal to 1/2 angle HGI. And that is by multiplication. I've multiplied by 1/2. We know by the angle bisector theorem that angle 1 equals 1/2 angle QPR, and angle 2 is equal to 1/2 angle HGI. So then by substitution, I can say angle 1 is congruent to angle 2. Then, because angle 1, now I have one angle to angle 1 up here, congruent to angle 2. I have Q congruent to H. We have triangle QPS, similar to triangle HGJ by the angle similarity postulate. Let's put a little similarity symbol next to it so that I don't confuse it with congruent triangles. Even though angle is not a way in congruent triangles, we're going to have some similar ways as we had in congruent triangles in the next section. Our last step, since I have congruent or similar triangles, I can now say that the corresponding parts are in proportion, which is what we needed to prove. So PS over GJ is equal to QP over HG, and that, watch my reason here, corresponding parts of similar triangles are in proportion. So there is our entire 7-step proof in a little bit larger of a screen for you guys so you guys can see it. There is your lesson questions. Why don't you guys, you don't have to do the 4th one. Why don't you just do 12, 14, and 18 and make sure that it's turned in by the due date.